Welcome to my session, Continuous SQL with Kafka and Flink, and we'll cover these two frameworks and a little else around that, and show you how you can run SQL queries as applications, and these can be run within a tool that makes it easy to run them, or you can embed them right inside your Java, Scala, or Python apps, probably Java. I've been working with data streaming, lots of different technology for a number of years. I'm based out of New Jersey in the Princeton area. I run a meetup there. I've worked at Pivotal doing Spring and Cloud, worked at Hortonworks, a couple other companies. And as you can see, I've been doing Java for a pretty long time. I don't think they still take those Polaroid pictures of you with Duke anymore. I run a weekly newsletter, covers a lot of different things from streaming, big data, different frameworks out there, different example tools, applications, Java code, some Spring stuff, all over the map. Like I mentioned, have that meetup. All of that is hybrid, so we make sure we stream that out to the general internet. And if you're can't attend, then we always make sure we have a recording of it and we post that to YouTube. So I do a style of programming called Flank, or I call it the Flank stack, which is using a couple of different streaming platforms together to make it easier, everything open source. And it could take the skills of a data engineer, Java developer, and really move you forward a lot easier. So you're not wasting your time writing code for things that don't need code. You write the Java code for the most important part of the application, the part that needs customization, business logic, the hard stuff, not for, generic things that can be done with SQL, or we show you also with Apache NiFi, which is also a Java application, to show you just do the code you need to do, scale things out as big as it needs to go, and move your data wherever it needs to go. There's a couple of frameworks in here, and you might have heard of Spark, which is also JVM-based framework. Why might I use one thing or another? And we'll show you it in practice, but practicality, if you're doing some kind of batch workload and you already have a Spark environment, that's a good place to do it. And maybe the data is going into something like Apache Kudu or Apache Iceberg. Good way to put big chunks of data that happen slow. And you could write the code in SQL, you could write the code in Java, Scala, a couple of options there. If you've got stuff that normally is a lot of boilerplate, you're writing the same field, you've got to write all these giant Java beans with 100 fields, maybe they change a lot. Maybe I had a friend had 50,000 tables he had to do that for. Do you want to write that code? I don't think you should write that code. Apache NiFi is a framework designed to do that for you, and it scales out to as many records you need to do at once. I've got a few telecom clients doing millions upon millions of events a second, and it's all drag and drop. If you need to do anything custom, you write custom Java code, deploys it to this environment, and handles automatically deploying and handling things in a cluster. You don't have to write anything special. You don't have to write any really complex, real-time code. It handles all the difficulties for you. Really nice. And today, the really interesting guy is Flink. Flink scales to a tremendous manner, supports writing code in SQL, as well as writing in Java and Python. And you could do a lot of interesting things. And anything you do within SQL, you can convert that into code, or you could take that query, put that inside a Java application and just deploy it and have that scaled out into massive clusters. If you're interested in doing this in a production manner, you probably want things like security and governance and observability, all those kind of things you might want to be able to deploy it in different environments. There's something called Cloudera Data Platform that makes that easier. So you don't have to do that by hand, and then also has Spark in there and Iceberg and all those other tools that make things a little easier. In a typical application that we do in this type of Flink and Kafka and hand streaming environment, tend to have a lot of different data sources. I'll show you a couple depending on how much time we have. If I'm speaking very fast and there's no questions popping up, probably get to show a bunch of extra demos. But lots of different types of data, really easy to bring into this system. Things like live question and answer, from Slack or somewhere else. Things like travel advisory, the weather, database changes as they happen, different transactions, public data feeds, wherever they may happen. I can grab GitHub and Wiki and news, all those sort of things. Different files you may have in cloud storage, live chat, whatever the data is, doesn't matter if it's structured, semi-structured, unstructured. We could pull that in, parse it, enrich it, route it, do real-time alerting on it. Typically, the work case is someone gets the source, and that's depends on what's easier for you. It could be with NiFi, which does this with a simple drag and drop, or it could be, a Spring microservice. Could be Flink can grab a lot of these sources directly. Maybe something like Kafka Streams. You got a lot of options there. Collect the data. Typical next step is get it into Kafka so it can be distributed among whoever may need to use it, which means I can have a Spring app consume that data at the same time as a Flink app, as a Kafka Connect app, what have you, even a Python app. They could all read this data concurrently without having to slow yourself down. The slides, I'll post the link to the slides as well, but there is in the JCON World site where you click the link, there is a link to the slides, and I'll post a SlideShare version of it over there as well. And also easy for us to talk to vector databases. Again, if we have to do something like LLM, getting that data quickly to either get stored in a vector database, get somewhere else for augmentation, however you're combining that. Very easy once it's in the stream, get into something like Kafka and have other people consume it as fast as they're able to, which may be slower for something like Spark, faster for something like Flink. Maybe you consume it in batches. Maybe you consume it every event that comes in, and we'll show you consuming an event as it happens. And that's how you get that continuous SQL, where as things happen, they show up in the results. They can get pushed downstream because I could do things like insert. And it's not just Kafka we can read real time. With the power of change data capture, I could read from databases like Postgres or Oracle or DB2, MariaDB, MySQL, what have you, different JDBC stores. And as someone puts a new event in there, an update happens, an insert, I can get that data and have that come into my query real time. And data can come from events, logs. There's a ton of different places data comes from. Very common. It starts off at an edge, starts off at a log, at a server. We get that data. I do the simple routing and transformation, get it into Kafka, and then people who need to write apps can do that afterwards. Flink can handle a lot of those, but clearly if you have front-end application or if you have existing apps out there, very easy for Java, Spring, any of the frameworks there have very easy mechanisms for consuming Kafka messages. That is extremely easy. So that makes things very easy to, once I get that data in stream, it could go right to a data store. At the same time, someone's using that in an app immediately. Each event could get pushed into Flink, and Flink can run real-time queries there. And you could decide some of the other consumers may wait to get a batch of data. Like your app may only care about, maybe I refresh every minute or every couple of minutes, but Flink wants each an event because I might want to do something like, check for fraud, check for things that need to happen immediately, or I could set up a window where I can look at data in the last 5 minutes to see, hey, someone used this credit card and did the same exact transaction 4 times in a row, and it looks suspicious. Flink is really nice for that. But let's look at Kafka first. Again, having this as the dashboard to send my data and distribute it and have that separation of concerns. Because as soon as I get it into Kafka, the producer of the data, you don't have to worry what happens to them. If that crashed, they produce something else. It's separate. You're disconnected. Very easy to have your other consumers start getting that data. So you could have as many different producers. Maybe they start and stop. Maybe it's continuous. Doesn't really affect the downstream users of that data, which is great. There's a lot of common use cases. These are a couple, and I'll show you them in the code, but I want them in the slides so you can look back at them. Again, having things decoupled, having many-to-many, really nice way to be able to get data in. If a Java app does it, if a commercial off-the-shelf program gets the data into the stream, open source, sometimes it's cloud, sometimes it's on-premise, sometimes it's the device. It doesn't matter. People agree on what Kafka cluster I'm talking to, wherever that may be. Could be on-premise, could be in Docker, could be in Kubernetes, could be in any of the public clouds, something like Ivan or AWS, wherever it is, get it into that topic, and then whoever subscribes to it will get it, or you can grab from it on demand. Lots of different options there. This scales out very nicely. Again, with most of these things, it pays to have an idea of how big and how much data you're going to process before you do it. So you can find get additional nodes when it's the best price, properly size things beforehand with enough RAM and cores and disk space. But within most modern environments, you could scale up and down without too much trouble. But again, if you know beforehand, makes things a little better, may save you some money, which is always nice. So are we streaming? We've got it into Kafka. If no one pulls it out, is it streaming? Yeah, but it would be nice to be able to pull that data out of Kafka and do that quickly so I could run my applications. And again, whether this is just using SQL or using it through the Java API or having Java wrap the SQL, doesn't really make a difference. Once it's deployed, it scales up as big as it needs to go. Again, depending on how many nodes of a cluster you want. Are you running on Kubernetes? Who's running this for you? You've got someone like Cloudera or Ivan or AWS handling your Flink cluster. Maybe not a concern other than, costs, how many things you can get done in the time. But for a source like Kafka, as soon as a message goes into Kafka, I can get that into my SQL query. Some of the other ones may have different time factors. Some things support semantics like exactly once. Some of them may not. It really depends on what you're talking to. Some databases aren't as good as that. Some of them have a little delay before they'll put a change from a change data capture into our system. And with Flink, with CDC, I don't have to use Kafka to get that right from the data store, and I'll show you that. But we can use Kafka to do change data capture as well. Depends on what system you have in place, what drivers you have. Again, trying both things. So common use cases, get data from somewhere, maybe a Kafka topic, maybe a Postgres table, get that into a query and have the results. The results can go into just a query for analytics. It could go to a sink that could be Kafka, could be a database, could be Iceberg, Kudu, HBase, different places you might want to push your data, or, something like a materialized view. So people who aren't doing disconnected things can get the last 100 records or the most recent data and get that through a REST endpoint without having to worry about what is distributed programming. Do I have a Kafka library here? What if I just want to grab the data once a minute? I don't want to think about it. Don't want to have code. Maybe just do it with a simple flat JavaScript page. You have the options there. Query just runs. It doesn't stop. It's just waiting for data. Clearly, you could end it when you want, but typically you're running these Flink SQL applications forever. They're just waiting for more data to come. And typically those events are coming, sub-second. And as soon as they arrive, we get them. This is not a micro batch. As soon as events are available, they're in there. This is not, super, super real time, as someone told me, with something that's running on a hardware clock and we're in a special embedded system. No, this is event came in, probably sub-second, but it's not, 1/100th of a millisecond there. It's fast. The SQL is very rich. It's based on Apache Calcite, which is a very strong ANSI SQL. So you could do selects, you could do joins, you could do group bys, all these sort of things pretty easily, and I'll show you some of them. I have a tool that makes it a little easier, so we don't have to run this from the command line, but it's pretty straightforward. I mentioned those materialized view. We make this as a REST endpoint, so you could use it in a notebook. You could embed it in any kind of program without having to worry about it. We could send our data to Iceberg pretty easily. Now, if you want to get used to this, give it a try. There is a full community version out there in Docker, runs a full Flink and Kafka cluster with this SQL Stream Builder tool to help you run it. Makes it a little easier. This is just something out there. This is a great way to develop and learn. And I'm actually running the demo in this environment. Pretty straightforward. If you want to run Apache NiFi as well, that lets you do that ingest. You could also run that in Docker pretty easily. It has some security there, so we'll go through that. I have the examples in the slides again, so you could look at them later. I don't know how quickly they post the videos from these events, so if you're curious how they're working. So I'll show you this in the real environment to give you an idea what's going on, but just to have them here in the slides. I also have links to some articles on a few different use cases, which are pretty common. Things like real-time ingest of transit data. Transit data tends to update pretty frequently. Like for this one in Sao Paulo, Brazil, they have, hundreds of buses. They're updating every time they're moving. They're at a different stop. Some alert condition happened. This is a lot of data. We get that injected. I push some of the messages to Slack, some right to Kafka, and then we can run our queries on there. And for this one, I build a materialized view and use that to build a dashboard pretty easily. And these are just leaflet.js and query tables, but this will just pull that data from that REST endpoint. You don't have to do anything special. And then we do one with real-time planes. I'll show you that in a minute. Again, that was a long time ago. I don't remember what year, but that was around Java 1. So it was fun times then. This is links to a couple of the Java APIs. So when you want to get into that, a deeper link to CDC, one on building a modern stack, and some other source code. Again, you'll get these slides, but I want to get into demo and questions so people aren't looking at too many slides. It's not slide day. So this is the GitHub I posted. This has examples of the Flink queries. And here is one where it shows you how to build the table. Now, some of the tools will build these tables for you automatically by looking at the data that's in the stream, or looking at a connected schema. If you push the data as Avro, it'll have a schema either embedded or it'll point to a schema registry. There's a number of schema registries out there. Cloudera has one, Confluent has one, Ivan has one. There's a number of open source ones out there, but you can get away without having them. Again, when you define your table, you could just define all the fields there, and then that'll be available in your SQL, just to give you an idea there. So I have some data coming from the edge. I have a device just out of reach here, so not really that remote. That's grabbing the data from an antenna that picks up local planes. And just to give you an idea, not too much plane traffic today, but a couple. And even with my tiny little antenna sticking out my window, I could see a lot of different traffic in the area. Just to give you an idea, we're grabbing real data there. So that's coming in, and then I'm pushing it into a stream. And we got our metadata, so I know things are running. So that's happy. So next step is, if things haven't timed out while looking at all these slides, which they might have done. Let me make sure we're still logged in here. And we're logged in. That's good. So in here is my NiFi code. This is a NiFi server running locally. This is running Java JDK 11. Can also run on 17 and higher. The next version will be running on 21, but for now, you can run as low as 8 in some versions. Obviously, no one recommends 8. Even 11's a little kludgy. So this is running in NiFi. So I've got that plain data coming in. As you see, the data is going up. What's unique about NiFi, besides the fact that I don't have to write the code and I can see everything visually, again, I got links to code that I've written in here and deployed as one of these modules. But I could see what's going on with the data. And here I have it paused and I'm not losing any data. And I did that so I could show a lot of data coming in through the system while we're doing the demos. So I'm pushing the data for planes into a Kafka topic. And we'll make sure we're getting data showing up there. Not in this one. Let's find the right one. Here we go. ADSB. It looks like junk. And the reason why it looks like junk is because I'm sending it as Avro. Avro's not really human readable. But since I have a schema, I could use the Kafka deserializer to see it, just so I could see what's happening in stream. And you can see data coming off the plane. This is the plane antenna, gives me data about its altitude, the name of the plane, how fast it's going, where it is. Again, we saw that on the map, so I know the lat and long, where it is and how high it is above me. Kind of cool. So we've got that data, and I could see, let's make sure this is current. That is the real time for us right now, for me here locally in the US. That is 12:23. 12:23. That's pretty close to current time for me. So the data is making it into Kafka. So I know I should be able to get this in my query. So I'm going to go into my environment to run Flink SQL. And if you look, you could see data starting to come in. I'm joining this with another stream of data, which is the weather data. So I'm going to make sure I have my weather data coming in. Make sure that screen didn't time out. Maybe it has. And that's, oh, no. I'm just getting all the weather in the United States. It comes in this giant zip file. That's the easiest way. Otherwise, I'd have to call them for every airport and location in the US. It's something like 4,000. That's kind of a pain. Instead, I'll just run and grab that zip file of all the files, split them up. You can see there's couple thousand there. All the ones that are legit, I pull them out, and then I'm just going to push them out into Kafka. Pretty easy. I also add a unique ID and a timestamp because they don't give me that in the XML weather forecast. And then I'm just going to push it to a topic as JSON. It was easy to work with, clean format, probably not the worst. And again, we can make sure we're getting that data in. Let me make sure this is the most current. That is 12:25. That is my local US time here. So data's coming in. That's a good thing. And as you can see here, I am grabbing some of the fields from the weather, and that is the location that the weather forecast is, and the station ID of where it's doing the forecast for the weather from, adding the Latin long, give me a pretty good location there. Then I'm grabbing the flight number and the unique type of plane it is. I get the altitude, speed, plus some of the weather data. And this is coming in as more data is being sent through the system. And what I'm doing here is linking that Kafka topic you saw for planes with the weather one, and I'm connecting them. I've done outer join. I did a couple things, but with the weather, they both have Latin long. Now, there's complex algorithms you can use to get things within a range. I'm doing it pretty basic, but it's coming out pretty close to accurate without having to do, a couple of pages of complex math, though I could write that in a function, which I could write in Java or JavaScript and call from here to do that. But to keep the algorithm very simple, I'm just doing where the lat and long are within a small variance. And if you plot that, you can see that it's pretty close. It's close enough for me to get the weather stations in this area. So the planes here, I'm grabbing the weather stations from Trenton Airport and the military airport over there in Lakewood, and then everyone's favorite airport, Newark Airport, which has all those great delays there. And we could just see the weather and the things in that area. Pretty easy, but you see we're joining them based on, a fuzzy lat long. We could do outer joins. We could just grab one table, but this is just one example of how you can take multiple streams of data, connect them, and here I'm pushing that into a materialized view. And that was the one we showed over here. And this is the current value. Again, it's cached. So if, say, my stream goes down or data slows up, I'll be able to show you something. So if you're connecting with an app, you could see recent things in your data without having to, do too much stuff. So that's a nice thing. And that stream continue to run because I get more data coming in, and I could run additional streams there. Now, besides that, there's a lot of other things I can do. I have a bunch of jobs, and these can be deployed to production. Or once I'm happy with this query, maybe I'm going to want to write a custom Java function to give me a closer match on lat long. Or maybe if there's none that's close, use one that's statewide. There's a lot of extra programming I could tweak. So I could take this query, put this inside of a Java app that's using the Flink libraries, maybe tweak that location mapping, maybe add some extra data, and then deploy this and have this run in a Flink cluster. And it would run the same way this one does. And you'd get this. Now, on this one, I'm only running on one or two nodes, but this could run if it needed to based on the amount of data. It could be deployed on a 100-node cluster. I've got a company I work with that has a 5,000 node cluster. Each node has, 500 meg of RAM, 500 gigs of RAM. And, you could scale out as big as you need to, as many cores. And again, you got those two different sources, one from the weather, one from the airport data. We join them here together, get the rows that are out, and we could track what's going on, see if there's any errors, set up checkpoints so if something crashes. pretty easy way to see what's going on with your system. And all this is REST enabled. This is all in the open source. And I also have another job running here. We could take a look at that one. What this one is doing is this one is hitting a table for CDC. So whenever it gets new data, it's going to display it. It's very easy to create this type of table. It's just that standard table we saw on the other one. But here I'm connecting to a Postgres server, and I'm saying use the CDC connector, right to my table port, things you have with a database, pretty standard. Now, not much data coming in here, so I can go and add more data to the table. And the way I do that is I'm grabbing data from a public RSS feed for bus advisories for near me. Again, I'm checking the planes above me and the buses near me, get that into the system. And here I've got something to slow down the data. So I'm sending a trickle of it in. So it makes for a nice continuous flow. Otherwise, this data is done in, a few seconds. And then that's not really good for a demo for you to see 1 second demo. So I'm sending the data in slowly. So what you're seeing here is I'm grabbing data from an RSS feed, converting it into JSON, and then doing a insert into Postgres. And every time a new record comes into Postgres, Flink CDC connector is getting that. It's using a project called Diesem, which is a pretty awesome open source project for getting change data capture from a lot of different databases, including Oracle, Postgres, SQL, Mongo, number of other things. And as you see, as new things come in, we just get them here. And again, I could do something like do an insert. So if we look at some other tables, like here, I've got a different table. So if I wanted to insert into that, all I'd have to do is insert. And inserting is pretty straightforward. It's insert into table as select if they have the same fields. Otherwise, it's the standard SQL you have. And there you're inserting it into another table. Or I can insert it into Kafka. Or I can insert it into Iceberg or into another data store while that data is coming in. Or I could just use this as data that feeds an application. Again, I could wrap this inside of a Flink Java app. And as I get each row back, I could do my own local processing within Java, and I'd get this back in a format that I could work with pretty easily in a table format. Depends on what you're happy doing. Again, if it's something simple, keeping it in pure SQL will make your life a little easier. If you want it a little more complex, obviously you could write pretty complex programs here, and it works well with Spring and all the other big frameworks there. So that's two examples of using continuous SQL. And again, like I said, they're both running at the same time here, even on my tiny little Docker. Now, if you're running this in an environment, you can run as many of these as you need, again, sizing them appropriately depending on the amount of data. Checking to see if there's any questions in the chat. Definitely feel free to ask anything if there's something that interests you. If not, I'll show you a little bit more of the features here to give you an idea. Again, this is pure open source. This tool here is not open source, but all it's doing is calling the APIs for you. This is just a good way to do it. There's one built into Flink from the command line. It's not quite as clean and easy to set up these jobs or tables or all that other fun stuff here, but all of this can be done by hand within code or within the command line tool, depending on what makes sense for you. Pretty straightforward to do that. Like if we could stop this one, again, this is just yep, I know I stopped it. I probably should stop sending data in. I'll let that pile up over here. Again, not losing the data, so if I want to do that later, I could do that. Again, if you haven't seen NiFi, you'll be able to see what data is coming in, all the metadata, see point of time, what data is coming in. So if I wanted to validate, like, okay, let me check to see if this is in the table, I could check the unique ID, see if it's there, and just do a query against Postgres or against Kafka to see, did I get that in those records? Like where am I sending this to Kafka? See if it's the same place. And here I can look through all the metadata here. There's a lot of it. So that's going to the topic New Jersey bus. So I could take a look at that one. I'll just go here, New Jersey bus. Okay, some data's there. And take a look. Again, that looks familiar. When I start seeing weird stuff, it's probably Avro. There's the schema, but now I could see the data. Pretty straightforward. If I was running that within Spring or a regular Java app, I'd have to make sure to use that schema to decompose the data. Again, not hard. The Spring stuff for Kafka is very good, and so is the regular Java APIs. It's one or two extra lines to be able to pull back Avro versus, raw data or string or JSON. Pretty easy, but this makes it no brainer. So we've got that data in there. Another thing I want to show real quick is a kind of cool feature. I'm still trying to figure out what's the next part to do, but what I have here is a Slack channel, and I can ask questions of Slack. Remember, we said that was one of the types of data. So I put in a question. What happens is I have Slack sent to push every question to my server. I get that as an event, and then I take a look at it and see what does this data look like? And I'm checking to see if this is a regular question and it's not about the weather, not about stocks. What was the question about? It was about the weather. So I'm just calling a weather API to get that. No reason to use generative AI to try to figure out the weather. That's just silly. What is the current stock price for IBM? And that is also doesn't need any AI to figure that out. It just does Yahoo get the current stock price. Not a bad stock price. So you get that. And if I wanted to ask some kind of question like, um, can I use Java to write Apache Flink applications? Clearly, that's not about the stock or weather. So that's got to go through the regular path here. I clean that up, build a call up to an API, and I'm going to call the Llama model, which is pretty decent for answering questions, get the results back, and send it to the Slack channel over there and have those results back. And if I look my results here, oh, that's not the newest library though, so they probably should do that again. If you look in my thing, we're on 118, so it's a little older, but it gives you a little bit to start with. Very cool. So we could pass in this information as an existing prompt and have it add more, but you get the idea. Can answer some questions. Again, I wouldn't have it to answer the weather. That's kind of silly, or current stock prices. And again, that's the power. I was thinking to write some custom Java, and I've done that before, one for natural language processing, one for anything I want to write and just write it in regular Java. It might make sense for me to write a Java application that figures out what your prompt should do. Should it look up stock? Should it look up weather? A couple different options. Because what I'm doing here is using some custom Java code here to give me the results back on your call. And what I give back is the name of the organization. That's how I could use that to look up stocks. So I get that name of that company. IBM happens to have the same name as its stock, but computer doesn't know that. So I call a REST service that converts company name to stock value, and then I use that to get the current stock price and then post that to you in Slack. But again, I could also push that to Kafka, and then I could have had a continuous query running against that to do something. Again, depends on what you want to do. I know we are running out of time here. Checking if there's any questions. If there's no questions, I'll spend another minute or two before I shut it down. I want to make sure the next speaker has plenty of time. Things seem to be running pretty well now. But if you want to write Java, it's very easy to plug it into any part of this equation, but don't write it when it doesn't make sense. Like, I didn't need it here, but I probably need it here. This would probably be a good Java function, and I know there's some out there to determine, nearness within lat longs so that I can map it pretty well. But you get the idea. Pretty easy to take lots of different data as it's coming in and, build analytics around them, make decisions, push data somewhere else. I could just take this combined data and push it right into Slack. There's a Slack sync for Flink. Again, you got to decide when do I stop where I am? Do I do it in Flink? Do I do it in Kafka? Do I do it in NiFi? Do it in a Java app? Kind of wherever it makes sense for you, where you want your last bit of code to be, or whatever's easier is usually the correct answer. Figure out the easiest place to stop there, and go on from there is probably a good idea. Now we've got different types of queries, max, group by, as you expect to do. Here I've got an outer join, a left join. Ooh, that should have been an outer join. Yeah, you could run full outer joins, left outer join. The syntax is pretty standard, but you could do a lot of things, even though these may or may not be underlying tables. It could be a Kafka topic, could be a table in a database. Depends on what you're doing. I don't see any questions. I guess it's just about time.